coming into this not always knowing what the material strengths are. Quite often we don't even know what the material are. So carry out material tests. You can take samples. Steel, you can take a coupon and send it off for testing. Concrete, you can take a cylinder, extract a cylinder and get it crushed, and so on. So that's the material side of it. Then you look at the loads. Have we modeled the loads accurately? Have we overindulged or overloaded it in our analysis model? If we don't know the loads, can you carry out load tests? Now, very simple load tests in buildings usually involve water bags. You get a bag, fill it with water and see how the building performs, which is usually the deflection of the floor or the deflection of the beams supporting the floor. So it's measured loading using with an in-situ test, and that gives you a best estimate of how the floor or the beams perform under their load. If they perform poorly, you may end up putting restrictions on the load. The other aspect of the structure, of course, is how it's supported and how it's restrained. And are those restraints and support conditions known accurately? If they're not, then you need to expose it. Quite often, the weak parts are the connections. And so you may need to take a piece of cladding off or a piece of ceiling plasterboard off and expose those connections, have a good look at them, see whether they're actually doing what they're supposed to be doing. Once you've done that, you can then refine your mathematical model, find alternative load paths if possible, and then give a more accurate, detailed assessment of the building. And that takes you back to Flowchart 2.